everybody for joining here and also over Zoom. I hope you can all hear well now with our system here. Thanks, Klaus, João, and also the other organizers for the opportunity. This is part of a current sort of short postdoc project that I'm making here at the Center for Philosophy of Science. I finished my PhD here last year, and now I'm doing this sort of 1-year project where I'm studying, among other things, AI and music, but focusing more on the case of recommender systems, and I'm going to explain why during the presentation. Different from the previous ones, it's not going to be, in case anybody has seen, it's not going to be so technical. That's far from my expertise. So I'm focusing more on the social implications. So I'm approaching it more as, you know, like people that listen to music or communities of music listeners and so on, and people interested in music. So how these tools are transforming things in several dimensions. So, and what I'm going to be doing today is mostly trying to identify and break down some of the main types of applications of AI in music nowadays, because a lot of the research is done about creativity, but as I will show, there's many other things being done right now. And why I'm doing this sort of differentiation and trying to break down these different types of applications is because I think they raise different types of questions, including in terms of philosophy and philosophy of science. So, and also cognitive science. I think some different applications that go beyond creativity raise different questions, and I'm trying to more or less formulate them. There are some examples I'm going to try to play, like they're through YouTube, just some samples of some things that are being done nowadays. Let's see if it's going to work. If it doesn't, I am compiling this in a playlist on YouTube. Later, anybody can just write me and I can send the link. It's public with several videos, not only of the applications, but also of some comments of, for example, musicians that are dealing with these or people from the industry commenting on these. There are things that you can find, but they're already compiled. So, so the talk is more or less divided into these 4 parts. I don't know if I'm going to have time to speak of the 4 of them. But they follow more or less also chronological order. These dates are not precise, they're just indicative. And we can see how since the 50s until now, the amount of different things that are being done and how they start raising more and more, especially social concerns, not only, let's say, in terms of creativity as such. So there's the part of the creativity, which is where this interplay between AI and music starts. Then you have this thing that I'm working on my postdoc right now, that is how AI starts getting closer, like a bit farther from the problem of creativity and closer to topics traditionally studied under music aesthetics. And then these 3 other parts, the 3rd and 4th part, I comment on examples of things that I found that are being like done, some of them like this year, some of them like 2-3 months ago, and that cannot really be classified neither within a music aesthetics nor creativity. And they mobilize some other things that I think we're yet to understand. But before starting like more with this specific cases, what I wanted to comment, I don't know what is the background of the people listening to this talk, but it's perhaps not so clear why we should be so interested, or why the case of music and musical AI should be so relevant nowadays. So it is self-evident that we should be interested in changes, for example, brought about by AI in medicine, economy, and politics for very concrete and immediate reasons. After ChatGPT, more recently, we also become more aware of the importance or the impact of AI to language and education. But the arts and music is perhaps not so clear to everybody, but I think that there are some very concrete reasons on why we should look into this. And I listed here 2 that gather actually many subdivisions that I would like to stress before we start. So before the fact that the consequences of AI for music are relatively understudied in comparison to this other area, I would remember that, so first, the music is a universal phenomenon, which is very closely linked to economy, politics, human communication, and even in a way to medicine or like mental health and psychology. So this means that if AI impacts one or more dimensions of musical cultures, this impact is very likely to be associated with changes in those other fields too. And the second thing that has more to do with us from history and philosophy of sciences is the second point that I listed there, which says that differently from other arts, the history of music goes hand in hand with the history of media and with the history of science. So, for example, from notation systems to the magnetic tape, radio and digitalization, from mathematical theories of music to acoustics and physiology, we can say that there is a documented history that shows that music is particularly sensitive to techno-scientific transformations. And therefore, it's expected that the impact of AI in music is not going to be something marginal. It is likely that it will be something that changes music significantly, including its aesthetic, political, economic, and social dimensions. And of course, AI might revitalize and might have something to add here in this long tradition of debates about music. Yeah, so, but basically what I was saying is that I think music has the implication for many other areas, and this is something historical. It's not just about this, the case of AI, but that will be a bit like sort of the motivation to look into this. Huh? So now I'm going to start with this series of examples in the first part. So as I showed before, like here's not sharing the screen, but these are more or less the 4 parts I'm going to be going through. So the implications of AI to musical creativity, and then aesthetics, and then these 2 more recent trends that are related to music and well-being. This is a very generic name, but you're going to see the examples. And the popularization of music generators. That is something like very, very recent. So about music and creativity. So the idea of treating music as an acoustic and temporal form that is governed by mathematical rules is something very old in Western cultures. It basically already starts with the Pythagoreans, and it never ceased to influence music theory since then. But this principle did not inspire only theories. It also inspired the idea of calculating machines that should be able to compose music. And this principle appears already in authors such as Leibniz, Athanasius Kirches, and Ada Lovelace. So we're talking about 16th, 17th, and 18th century. But since the 50s, scientists started to explore this application of computers to generate music. And the first example that I'm going to try to show, let's see if it's going to work, that is considered like the first piece of computer-generated music is this Iliac suite. That was based on using algorithms to analyze musical notation and extract like mathematical patterns from there, and then use that to like through recombination. It's basically a combinatorics to generate new music from that. It's something for nowadays still very, let's say, simple or incipient, but yeah, just to give you an idea of how this started in the 60s. And sorry about the YouTube ads. I think they're going to be plenty of them. We had a technical problem earlier before. And this was basically like a kind of a university research project to use computer. Like it needed a lot of computational power in the 56 to generate something like this. And this is how it sounds. I think here we're going to hear. If people on Zoom don't hear it, please let us know. But I think it should be fine. And so on and so forth. Is like a counterpoint played by, this is played by real musicians. It's just composed the score, the notation was composed with computational algorithms. Let me go back now to the presentation. Where was it? Yeah. And this is another example that follows more or less the same lineage. Like if you look for this David Cope online, he released like several albums and CDs and worked with several types of algorithms also to generate music based on the style of Bach, Vivaldi, and Mahler. So his topics mostly using computational algorithms to understand the style in mathematical terms, to understand the style of certain composers, and they reuse it to generate the music following that same style. It's a bit more sophisticated than that first example. This is the example of the Bach chorale. He has plenty of these kinds of But again, here, like he's a computer scientist and a musician that has to design his own algorithms to do this. He has to convert audio into notation systems and then analyze these notations mathematically in order to teach the machine to compose this type of music. And what we're going to see here is that nowadays, these kinds of things are already ready to use. You can basically use much more sophisticated algorithms that are available online to mimic styles of different musicians. So just to have an idea. And so on and so forth. Here too, like only the music is composed, like it's written by the algorithm, but it's being sung by a human singers. Huh? And as I was saying, like nowadays, it's much more advanced. So, for example, you have from this paper more recent. So, deep learning is receiving orientation as an approach for music generation. And you have this example of Magenta from Google. Also, Spotify has their own research and development unit that works with these kinds of things. From David Cope, again, as I was saying, like he published these things also in books explaining in more detail his algorithms. So his main topic is whether computer programs can effectively model creativity and whether computer programs can themselves create. And this was just to give you an example and how this initial stage of the relationship between AI and music was much related to the cognitive science problem of modeling creativity. So the idea of creating a computational model of creativity. Like this is what these researchers were interested in mostly. Nowadays, who sort of continues this tradition is this research field named computational creativity, who is considered the subfield of AI. And that, as they define themselves, has to do with philosophy, science, and engineering of computer system, and also have to do with cognitive science and other areas. And yeah, and this is more or less how it started. But now we're still in this key of the creativity. What is interesting is that nowadays, not only you have more easy, let's say, ready to use algorithms, but you have there's sort of a new type of collaboration that is not so much the idea of using the algorithm or the computer systems to learn the music from scores, but it's also the idea of having the computer to generate parts of the music. And then you try to re-embody it by playing it yourself, which also generates a very peculiar combination. So this example that Alexander has been studying this for a while from this band called YAH, and they made a collaboration with the Magenta engineers from Google. And they created this album, which is, they trained the model with very short samples of their previous song, like it was a catalog of short, like 82 songs or something like that. And they output to several like small sentences or phrases or musical ideas. And at the end of the day, they made the composition. But what was interesting here is that these snippets or these samples of music that was generated by the AI, they had to use as it was in the output, so they could not twist it. And what they report, and this album is kind of a representation of that, is that they sort of had to relearn to play the instruments because you're so unintuitive how to play and to sing those things, which means that these are not so much only about whether computers can model creativity, but also what it can do for our expansion or, like this human AI collaboration, to which extent it can make us break from certain creativity habits and acquire new ones. And I put this example here just so you can have an idea of the kind of melody that it generated that is indeed quite unintuitive. So the musicians played it, they organized the structure of the song, but the melodies individually, they sound quite peculiar indeed. So just to give you an example. And also, not the song, I guess, but also the lyrics of most of the songs of his album was composed using these large language models, and the videos, they also used some AI. And so on and so forth. And you can see that it's a very peculiar kind of acoustic aesthetics that you have there. And but this is just like to call your attention for this idea of human AI collaboration that is becoming more and more common. Here's another example that is with robotics and the idea of this real-time improvisation with robots, that what the researchers report is also this idea that in a way makes you break with your habits, because like, you don't really know how to read what the robot is doing, and then they design a robot that tries to mimic human gestures in order to make a more, let's say, intuitive to humans, the communication. This is from a research center from Georgia. And this robot that's called Shimon, they have been developing it, so it also writes lyrics and does all sorts of stuff. But this is an interesting video because it has the gesture part of the improvisation. And so on and so forth. Because here the idea is that of they using the computer vision, because then he's understanding not only the acoustic structures, but also how it is played and embodied, which kind of brings this to another level. Like, yeah. Back here, let me just do something here on Zoom because I'm not sure. Okay, but this was all just like to give you this idea of the one of the main trends of interest in the relationship between music and AI, that is creativity. That starts with this idea of trying to model human creativity from a more cognitive or mentalist approach. And now you're writing this like much more like embodied and even situated that you perform together, like the attempt to model it on that level. But now I reach, which is I think the most important part here of the talk, that is where I'm trying to develop. That is that besides all that domain of emulating, instantiating, and expanding human musical creativity in or with AI, and the respective philosophical and scientific challenges of this agenda. So all the topics of the cognitive sciences we're saying, and nowadays a lot of the embodied cognition problematics is behind that, like how to instantiate that with computers. In the past decade, and more intensively in the past 5 years, there has been a profound transformation in the relationship between music and AI. And this transformation, I would claim, consists in a shift of emphasis from AI and musical creativity on the one hand, that is this kind of background that I gave now, towards AI and music aesthetics, which includes, for example, the use of AI in musical curatorship and the use of AI in the analysis of aesthetic experiences. So I'm referring here more like to streaming platforms, for example. And this shift of emphasis has introduced a whole new set of concerns that have quite a direct impact in societies on a global scale. So this thesis is firstly developed by Lev Manovich, who is a media scholar. And he has already noticed this in the context of visual culture. So he analyzed a lot, for example, the case of Instagram and media sharing visual culture in social media. So he says, for example, the original vision of AI is about automation of cognition. but today AI also plays a crucial role in culture, increasingly influencing the choices and behaviors and imaginations. While algorithms have been employed in artistic creations by artists since the 60s, for example, that first case that they show, today, industrial scale cultural AI is built into devices and services used by millions of people. Instead of being an instrument of a single artistic imagination, AI has become a mechanism for influencing the imagination of billions. And the main point that I would like to emphasize here is that there are new problems and new concerns that are raised from this change. And they go much beyond the issues of cognitive sciences related to creativity. And these new problems impact much broader domains of societies and cultures, as you will notice in the examples that I'll show next. The use of AI to manage musical curatorship and users' experiences, for example, through recommender system, that is one of the main sites of where this technology is developed. It also raises concerns in terms of normativity or cultural diversification, for example, like to which extent these models could constrain, for example, more cultural creativity or not, or expand it, for example. But it also raises concerns in terms of user privacy and manipulation of mental states through music and sound. And I think a very illustrative example of this is the case of recommender systems, and one of the first theoretical elaborations of the principles of this new application of AI can be found in this PhD thesis from Brian Whitman, who is a computer scientist. He first introduced this machine learning model in this thesis called Learning the Meaning of Music in 2005. Later, this was transformed into a startup called the Econest, which was later acquired by Spotify. So we're talking about a very a lineage that has like a lot of cultural influence nowadays. And the way he introduced this in the thesis, it's very interesting because it's a whole agenda of what AI can do beyond creativity. So I selected here a couple of, I'm not going to read through all of it, but just to give you a feeling of what it is, the kind of problem they are trying to formulate in the form of like a problem solving, AI-based problem solving. Let's put it like that. So it says, for example, that we want to find more music that we like, want to have our portable devices know which songs to play, and yet we still search for music only by file names, simple metadata such as artist, album title, through sales-based recommendation systems. But, and here's the interesting part, it says computers are better at making sense of large amounts of data. And the goal of his work, that again, it's, I think, kind of summarize what is a bit the goal of the research on recommender systems nowadays, in principle at least. The goal would be to make machines link music to semantic features of the outside world for the purpose of organization, recommendation, or classification. And we could also put it nowadays for generation with the whole hype generative AI nowadays. If we do it right, they'll have the same knowledge about music as the aggregator for entire community. They can tell you about similar sounding music or recommend a new artist, so on and so on. This is also an interesting part of the quote where it says, most of these approaches, he's talking about music information retrieval, ignore the meaning of music, what happens in between the music and the reaction. Retrieval systems don't know what songs are about or how they make people feel. They don't understand why some artists are currently selling millions of records. They are stuck inside a perceptual box, which inherits more this cognitive, the symbolic AI and so on. Only being able to feel vibrations without truly experiencing the effect of music. So his idea was to develop this machine learning model, like a whole computer architecture that would find where the signals of this meaning of music are. And then you can have, this is from Spotify, probably it's not updated, it's from one of the researchers in the presentation, which was the architecture of their Discover Weekly playlist. It was very similar also for other playlists. And you can see there in that, for you that you're seeing here in your right side, where they have like, where he's going to look for the signal that should point out to the meaning of music. So they go for play logs, track metadata, these web crawling techniques, also to look for people's comments, etc., etc. And they try to different special algorithms, you see that. So for example, the language processing, or these collaborative filtering algorithms, and so on and so on. Also analyzing the raw audio, which should be the musical track or the sound, and crossing all of that in order to try to make this, like what does music mean for people, how this makes them feel, why is this considered interesting or not, and so on. And this is, of course, a very vivid research field nowadays in computer science, the recommender systems. And note here that at this point, when he wrote this thesis in 2005, computers were already being used to store and process music-related data. But scientists such as Brian Whitman, and nowadays a whole community of computer scientists and data scientists, realized that with machine learning, computers could go way beyond simple information retrieval and start to participate more actively, almost as an agent, in shaping musical cultures of different societies. So AI could be used to automatize the task of the so-called cultural gatekeeper. So that's what's at stake here. Therefore, AI starts to play a new role in the domain of music, which is, I claim, not so much related to the problematics of creativity, but it has more to do with concepts of music aesthetics, such as the meaning of music, the experience of music, musical taste, how communities shape and develop their musical preferences, what is considered music relevant in a certain community, and so on and so forth. I have been calling this a data science music aesthetics. There's a paper that I think should be out still this year that if anybody's interested, I can share later, like where I analyze this idea in more detail. This idea of this kind of problem-solve-based music aesthetics has not ceased to grow since 2005, has generated a lot of sociological concerns already. So like here are 3 references that illustrate this very well. I'll just focus on this last one of Nancy Harahan, that she calls the attention, for example, how the social and ethical dimensions of aesthetic experience of music are affected by digitization, and even more if you think about the machine learning used to handle music digitization. And she argues that quantization associated with digital environments is altering the cultural form of aesthetic judgment, just as personalizations change the meaning of difference in this context. And so there's quite a debate going on among sociologists about this. Beyond sociology, and this is always one thing that I put even later after we were talking about some things, that beyond sociology, I think also these frameworks, for example, of the extended mind and also situated affectivity could be important here, which are more areas of the cognitive sciences. I just submitted a paper that is exactly about this topic. I haven't seen yet. There's a lot of work on the situated affectivity in music. So how the environment and material conditions transform how we experience and make sense of music, and how we communicate this experience, let's say, intersubjectively. But how AI is playing a role in this, I'm still not sure. I tried to develop some ideas on this. It's also an upcoming paper. And now I'm going to go very quickly so we have some time to talk in these last 3 parts. There are things that I was not even planning to talk about this, but when I started seeing more recent applications of AI in music, there was like a whole new, let's say, generation of examples that were neither about creativity exactly, but also not not about recommender systems of streaming platforms, or they somehow don't fit, although they rely on very similar principles. And the first group of examples, I'm calling these musical AI and mental well-being for the lack of a better name. But I first got to know about this in this paper from these 2 psychologists that is called Music and Big Data, which they kind of announce a whole new research agenda that again, it's neither about the creativity problem as in cognitive sciences, and it's also not about using AI to shape the music industry, let's say. Though it has to do also a lot of like psychology and research, scientific research. They say there's an unprecedented opportunity for psychologists and behavior scientists to major prior theory and research with big data. because there are now streaming services that store millions of data from millions of people on their day-to-day musical listening habits, song-level data that tags sonic and emotion attributes for millions of songs, wearable devices that capture physiological metrics, including heart rate and galvanic skin response, mobile technologies that track a person's moment-to-moment activity, location, mood, and sociability, and survey instruments and digital footprints that capture personality and other psychosocial metrics in just under a minute. We propose that merging these technologies can create a new age of music psychology that exponentially expands the present knowledge and the scope of the field. This new data will advance general areas of music psychology, but will also provide an important opportunity to establish new knowledge about health and well-being that can have a direct impact on the public. So this is the more research part. That's like a new research agenda. That again is not the music psychology exactly. It's also not the music aesthetics. It has more to do with psychology. But then here's the interesting part of the impact that this can have. Because they say, by scientifically mapping how music changes behavior and health in the short and long term, big music data can lead to future health initiatives, including the development of new evidence-based treatment modalities to be utilized by medical physicians and mental health practitioners. Importantly, industry and streaming services can use these new insights to optimize their technologies and develop music-based health and wellness platforms aimed at providing well-being for its users, ultimately impacting the way music is used by millions of people globally. So again, like this is another kind of trend that it opens up possibility of research. And there is other kind of concerns, because the idea that you have access to this kind of data and how you're going to use this, and if the users are aware that you can use this kind of things, and assuming that this knowledge can actually be generated with this kind of data, who's going to have access to this data, and so on and so on. And of course, the idea that you could like scientifically identify these correlations between certain musical and acoustic patterns and certain mental experiences, let's say. If you could actually control that, again, this is a big if, here they announce a research agenda, but assuming that you could get even close to that, these raise other types of concerns. And for the philosophy of science, which is something that we discuss more and we have discussed in previous seminars, we can ask to which extent this is possible, like an agenda of identifying this correlation with this kind of data. For example, one topic that I'm always trying to highlight is that usually in this kind of approach, the historicity and the cultural situatedness of these concepts are not really that well taken into account. So like, for example, the emotional reaction that somebody has to music, it can change historically, it can change if you learn new things, it can change depending on your cultural environment. So these are all challenges that this empirical research would have to deal with. I'm going to skip these other quotes here. If anybody's interested in a company that is offering exactly this kind of services, an app for you to try if you want to. The Endel is it's one that is doing this, and they also publish research. So if you want to have a more concrete example, and I'm going to skip that audio example. And now, just in the last part, what I wanted to comment is this latest thing that I have found. That is again this idea that in the lack of a better name, I'm calling it pop AI music generators, because it seems that there is already a new generation of algorithms for generating music that come from the traditional music creativity. But you don't need anymore to be a computer scientist to deal with that. So for example, you have these two, and in that playlist that I made, you can check, there's some tutorials. It's very, ready to use. You have, for example, the Newsnet and the Jukebox. I think both are from OpenAI initiatives that you can communicate to the system using natural language. You can upload models of the styles of music that you want to generate. Like you can put your own combination, like Beatles with something else. It doesn't have to be like just Beatles-like or Bach-like music. You can combine it, and you can give more specific instructions, and you generate new music that in principle is copyright free. So And the interesting thing is how this is being used and the kind of problems that is generating. So you have, for example, a whole new scene. I don't know if anybody has seen this here already, but of these homemade productions of people on YouTube. You don't know who they are, but they use these tools to make covers that never existed, collaborations that never existed, to put famous artists singing their songs, although these famous artists, of course, never sang their songs, all using these kinds of tools that are now available. And of course, then everybody talks about the copyright problems. So Universal Music has already put down some of these videos, but they proliferate again very quickly because they are not being monetized on YouTube. So of course, this makes us reconsider the question of copyright and ownership, because a lot of these systems, they're using the timbre of a certain singer, and and then if you want the timbre of your own voice, it's and a bunch of other questions. So I'll just show a couple of examples. For example, this is I don't know why, but Kurt Cobain became very famous with this thing. I suspect it's because this was one of the first ones that they put Kurt Cobain singing Black Hole Sun from Soundgarden, which is a cover that never existed, from two bands that probably everybody wanted to, that they wish they had collaborated, but they didn't. And as far as I know, this was one of the first ones that used these ready-to-use voice models to generate a model of Kurt Cobain's voice and put him to sing another song. And after that, there was a bunch of things of Nirvana. But so just to give an example how it sounds natural in a way, but the main thing is that this is ready to make. Like, it's not so much the quality that I would like to call the attention here, but imagine that you can do this without programming anymore.
In the stars, in the sky is no news. Every place, the flame, the sun in the spring.
Because you hear like some glitches in some parts that. And so on and so forth. You have lots of them being made. This is one of the first ones that I heard. I'll just show, I think, one. Well, I'll show all of them because they're just 1 minute each. So, of course, about this one, like that, I saw a lot of people commenting on this one in terms of quality. And of course, like everybody that knows about, like that if you listen a lot to Kurt Cobain singing, for example, one thing that some people mentioned, he doesn't do that kind of vibratos that are something very much like Chris Cornell that was the singer of Soundgarden. But I would not be so interested in this kind of point. It's more like on how easy it is to make it nowadays, and a different type of creativity that emerges. That is this idea that, I like certain bands, and how big they collaborate, like, and this can generate other things. This one, AISIS, which is interesting because it is a band that exists, a British band. They had their own songs. And then during the pandemics, if I'm not mistaken, the singer of the band saw some of these like AI models of famous singers, probably maybe even this one from Kurt Cobain. And he asked the guy that was making that thing if he could make him an AI model of the voice of Liam Gallagher from Oasis. And I think in principle, the guy said, no, I'm not going to tell you how I do that and so on. But then these tools start becoming more and more easy to find online. And then he created it. And he put the voice of Liam Gallagher to sing the whole album of his band, which promoted his band, of course. This is how it sounds. which also sounds like very, very natural. And last example now, that is the one that there are a lot of already media outlets talking about this one. There is a collaboration that never existed between Drake and The Weeknd, if I'm not mistaken. And this is one of the main profiles on YouTube that has been doing a lot of these things, this ghost something. He had another one that he got a ban from Universal Music, I think. And but he keeps doing it in other channels. And what is interesting of this example here, which is what's starting to happen now, is that you get this output here, but you don't know if the AI wrote the lyrics, composed like the beat or some melodies or something. The only thing you know is that the voice is not of those, I mean, like that, it's not really those singers that I sing, right? Like, so for example, here, it's gonna sound like Drake and The Weeknd. You know that it's not them, that they never sang these things. So you know that there's an AI model of their voice. Anything else, you don't know how it was done. Right? Like, so there's also this kind of a bit chaotic creativity going on of like these communities of people sharing these things, and we don't know where this is gonna lead. So it's the last example.
Cutting milk with my ex, actually, not a flex. I'm being just in there, but I played it, but I left. She knows what she needed, but I need it, all she best. I could pivot in my bed. She thinks that I need you, I'm to the car.
And so on and so forth. If you know the singers, I don't know them very much, but and yeah, there are plenty of those things out there. And I'll stop here and we can talk again. There is this playlist. Anybody that is interested, write to me and I can share, because I'm compiling a lot of this material there. Also, like these tutorials of people teaching how they use it, and some comments of experts from music industry and academics about that. And I'll keep updating that, so it's public. And thank you very much. I hope it's not too chaotic, but you should have an overview now of what's going on. Thank you.